Alkanes are saturated hydrocarbons and alkenes are unsaturated hydrocarbons. In the models here in front, we have ethane and ethene. You can see in ethane that there are only single bonds. That's true of all alkanes. That's why we say they are saturated. And in ethene, you can see the double bond between the two carbon atoms. Alkenes have a double bond in them, and therefore we say they are unsaturated because that double bond can break, one of the double bonds can break, letting in another chemical, another atom, and in that way it can absorb, assimilate something, and so that's why we call it unsaturated. And we are going to show the assimilation of bromine into an alkene. This alkene that we have here is not ethene, it's actually cyclohexene. And we're going to compare that to the inability of an alkane to assimilate bromine with as much ease. And the alkane we are going to use is cyclohexane. Now, here in these two test tubes, we have some bromine water. Bromine is brown. We're going to add some cyclohexane to the bromine, and you'll see that the bromine does not get taken up into the cyclohexane, into the alkane. We just shake it to give it a good chance, and we see the brown color remains, meaning there's still bromine there. Actually, the bromine's dissolved in the cyclohexane. You can see there at the top, it's a bit darker. The cyclohexane is floating on top of the bromine water, and it has not reacted with the bromine to take it into its compound and therefore decolorize the solution in the process. Let's try the same with cyclohexene. We add a little bit of cyclohexene to the bromine water, and then we shake it up. And immediately you see that there's a decolorization. What does that mean? That means that the bromine water has reacted with the alkene, and that's why you no longer see the bromine in its elemental form, Br2, which is brown anymore. It's now actually formed bromocyclohexene because the bromine atoms have gone into the space which the double bonds used to have, and double bonds have broken in order to let bromine in there.